Michael Faraday, in 1828, then through 1831, would do the Christmas lectures in London, which is back east someplace. And he did this demonstration where he had a coil of wire on one end of a laboratory bench connected to another coil of wire by two wires, the terminal wires of the coils. So he goes down here with a bar magnet, reasonably powerful magnet, which you could find in those days. So he moves the magnet at this end of the table, and the compass needle moves at this end, as if by magic. Of course, it wasn't magic, it was science! Yes. So the story was embellished, and it was presented to me that he did this demonstration with such success so often that he presented it to the Queen of England. And the Queen of England is supposed to have said to him, "Mr. Faraday, of what use is it?" And here's where I just admire the guy, and I admire what we in the United States perceive as the British way of thinking. He did not say, "Lady! What? Are you, would you look? That's at that end, I'm at this, I'm not touching it. What? Are you high? I mean, come on."
I love it.
But that's not what he said. According to the story, he said, "Madam, of what use is a newborn babe?" Now, I don't know how much time you have spent with newborn babes, but they're not that useful. They're loud, and they leak, and there's a lot of times they don't seem to understand a word you say to them. Look around, everybody. Everything in this room, everything, the lights, the curtains, the paint, the clothes you're wearing, the upholstery, the floor, the stage, everything here owes its existence to that discovery. To the discovery that not only is there a connection between electricity and magnetism, but there's a connection between electricity and the moving of the magnetism, the flux. And that discovery, dare I say it, changed the world.
Whoa, dude. This is awesome.
Definitely. Awesome.
I mean, like all those stars. Dude.
Oh, there's millions of them.
And like each one of those stars is like a sun.
Like, whoa. Dude. That means that, like, oh, there's tons of other solar systems.
Well, yeah.
Whoa.
And that means that we're like
little specks. Oh, like almost nothing.
whoa.
Quantum mechanics, quantum physics was discovered. That is the science of the small, the science of electrons, protons, neutrons, particles, nuclei. At the time, you'd say, this is just physicists burning tax money. Because who cares about the atom? I got my horse to feed. I got kids, you got issues in society. Yet it's quantum mechanics that is the entire foundation of our technological revolution. There would be no computers. There would be none of what you take for granted, your iPod, your iPhone, cell phones, the space program, without our understanding of the laws of physics as they operate on that atomic and molecular and nuclear level. And so the chemist has no understanding of the periodic table of elements without quantum mechanics. To them, it's just a list of elements. Quantum mechanics tells you why this column is there, and that's there, why this mates with that, and why that makes a molecule with that. That's quantum mechanics, and it's unheralded. You ask me, is there any discovery that has changed how we live? It is quantum mechanics. And I make this point because I'm ready to... Today you hear people saying, why are we spending money up there when we got problems on Earth? And people don't connect the time delay between the frontier of scientific research and how that's going to transform your life later down the line. So all they want is a quarterly report that shows the product that comes out of it. That is so short-sighted that that's the beginning of the end of your culture.
So it's...
Einstein went on from thinking about moving clocks to thinking about what happens to time and space in the presence of heavy things like planets and stars. And he found, or his theoretical prediction was, that not only does movement bend space and time, but heavy things like planets and stars bend space and time as well. And he made predictions about what that means. It actually means that when you're traveling through space near a planet, you feel like you feel a force, because you're moving through bent and curved space and time. That force is gravity. It's a beautifully elegant theory. In fact, I even wrote that down. That's Einstein's theory of general relativity. The whole theory of gravity, the best theory of gravity we have, in one line. Actually, this thing here just tells you how the mass of a planet or a star is distributed, and this thing here tells you how space and time curve. That's it. That's all there is to it. And then the picture is that as things move through this curved space, they bend because they're going through a curved space, and that's what we feel as the force of gravity.
If there was no concept of having stewardship of the Earth a million years ago, today there is at least a very great need. If you stand back from the Earth, as those Apollo astronauts did in the late 60s, and photograph the Earth from a distance in space so you can see the whole Earth, there's this blue aura that you can see surrounding the daylit hemisphere. And it's just the atmosphere seen edge on. And what is most impressive, what many astronauts have remarked upon, is how thin, how fragile, how vulnerable it seems. The thickness of the Earth's atmosphere compared to the size of the Earth is about the same as the thickness of a coat of shellac on a library globe of the Earth. There isn't much air. And so we now have the prospect of inadvertently endangering the life-supporting environment, the environment that supports the human species and many other species, of committing what religious people sometimes call crimes against creation.
Another aspect that I think is tremendously important is those photographs of the Earth alone in space, fragile, blue world, in this vast blackness, this vacuum, velvety vacuum of space. And it's clear, it's very thin atmosphere. It's so sensitive to the depredations of human beings. You look at that and you say, hey, that's only one little world. We don't have anywhere else to go. No other planet in the solar system is a suitable home for human beings. It's this world or nothing. That's a very powerful perception.
The atoms and molecules in your body are traceable to the crucibles in the centers of stars that manufactured these elements over its lifespan, when unstable, on death, exploding its enriched guts across the galaxy, scattering it into gas clouds that would ultimately collapse and make a star and have the right ingredients to make planets and people. Which means we are part of this universe. As I've said many times, and this goes back, not only are we in the universe is in us. That is a profound concept. And it was, I think it's the greatest gift that astrophysics gave culture in the 20th century.
It's a beautiful picture from the Hubble Space Telescope of a distant galaxy, far, far away and long, long ago. And there's a whole galaxy, it's about 1 billion light years away. We're looking at it as it looked 1 billion years ago. So many of those stars no longer exist. And here's an object that's just as bright as the whole center of the galaxy. You'd think it's a star that's near in our galaxy that just got caught in the picture frame. It's not. It's a star on the edge of that galaxy that has exploded. And exploding stars shine with the brightness of 10 billion stars. They're the brightest fireworks in the universe, supernovae. And they're remarkable, and I keep having asides, maybe I'll get to my point eventually, but this is something that I wrote a whole book about, and someone asked me yesterday why I wrote that book. Because it is the most poetic thing I know about the universe. Richard wrote a great book called, what's it called? Our Ancestors? What's it called? Ancestor's Tale, yes. I wanted to make sure I got that right. And I wrote a book that was a different ancestor's tale. It was called Adam. But the amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution weren't created at the beginning of time. They're created in the nuclear furnaces of stars, and the only way they can get into your body is if the stars were kind enough to explode. So forget Jesus. The stars died so that you could be here today. Okay? And anyway,